the approval to make the first cars maybe in October if we're fortunate.
In a groundbreaking announcement, Elon Musk has unveiled a revolutionary new water engine that promises to transform the future of transportation and energy. After years of skepticism and countless innovations, Musk's latest venture sets the stage for unprecedented environmental sustainability. But what makes this water engine so unique, and how will it impact our world? Join us as we dig into the mechanics of Musk's incredible invention and explore the far-reaching implications of this game-changing technology. Elon Musk abruptly announced a big change in Tesla's course on X, formerly known as Twitter, in an unexpected turn of events. Following years of doubt regarding hydrogen fuel cells, Musk declared that Tesla will switch from battery power to hydrogen power, which represented a significant shift in the business plan. This announcement caught many by surprise, given Musk's previous criticism of hydrogen fuel cells, which he famously called fool cells. The shift was driven by the challenges faced in mass-producing the 4,680 battery cells, prompting Tesla to reconsider its approach to sustainable energy solutions. But Musk didn't stop there. He revealed that Tesla's latest innovation, the revolutionary water engine, would be at the forefront of this transition. This groundbreaking technology promises to redefine how we think about engines, offering unprecedented environmental benefits and performance. So what makes this water engine so revolutionary? How will it impact the automotive industry and beyond? Elon Musk, the visionary behind Tesla and SpaceX, has always been driven by a commitment to cutting-edge technology and environmental sustainability. His goal is to create a future where technology enhances our lives while protecting the planet. Musk's relentless pursuit of innovation has consistently pushed the boundaries of what's possible, earning him a reputation as a modern-day pioneer. Musk's vision for Tesla was about creating electric cars, but about transforming the entire automotive industry. He aimed to prove that electric vehicles could be faster, safer, and more enjoyable to drive than their gasoline counterparts. This mission was about more than just cars. It was about accelerating the world's transition to sustainable energy. With SpaceX, Musk's ambitions extended beyond Earth. He envisioned making space travel more affordable and accessible, ultimately aiming to colonize Mars. SpaceX's achievements, such as the successful landing and reuse of rockets, have revolutionized the space industry, demonstrating Musk's ability to turn ambitious dreams into reality. Musk's journey in renewable energy and transportation is marked by several key milestones. Tesla, founded in 2003, initially faced skepticism. Electric cars were considered impractical and inefficient. Musk's perseverance paid off. The Roadster, Tesla's first vehicle, showcased the potential of electric cars with its impressive performance and range. The subsequent releases of the Model S, Model X, Model 3, and Model Y have solidified Tesla's position as a leader in the electric vehicle market. Each model brought advancements in battery technology, driving range, and autonomous driving capabilities, making electric cars increasingly viable for everyday use. Beyond vehicles, Musk's contributions to renewable energy are significant. Tesla's Powerwall and solar roof products are designed to create a sustainable energy ecosystem for homes and businesses. By integrating solar energy generation with efficient energy storage, Musk has provided practical solutions for reducing dependence on fossil fuels. In the realm of space travel, SpaceX has achieved remarkable milestones. The Falcon 9 rocket's ability to land and be reused has dramatically reduced the cost of space missions. The successful deployment of the Starlink satellite constellation aims to provide global internet coverage, further emphasizing Musk's far-reaching impact on technology and innovation. The water engine operates on a simple yet ingenious principle. It uses water to generate energy. This process fundamentally separates it from traditional combustion engines, which rely on burning fossil fuels, and from electric engines that depend on battery power. But how does the water engine work? At its core, the engine uses a method called reverse electrolysis. In conventional electrolysis, electricity is used to split water, H2O, into hydrogen, H, and oxygen, O. In reverse electrolysis, the process is flipped. Hydrogen and oxygen are combined to produce electricity, and the only byproduct is water vapor, making this an exceptionally clean technology. So what are the mechanics behind this impressive technology? The water engine's mechanics are a blend of fuel cells, reverse electrolysis, and hydrogen-oxygen reactions. Let's break it down step by step. First, water is introduced into the system. The engine then splits the water into hydrogen and oxygen using an initial energy input. These gases are stored in separate tanks within the vehicle. When the engine is running, hydrogen from the tank is fed into the fuel cell. In the fuel cell, hydrogen molecules are split into protons and electrons. The electrons are used to create an electric current, which powers the vehicle's electric motor. Meanwhile, the protons move through a membrane and combine with oxygen from the air, producing water vapor as the only emission. This process is incredibly efficient, continuously generating electricity as long as there is hydrogen and oxygen available. But how efficient is the water engine compared to traditional and electric engines? The answer is quite promising. Traditional combustion engines have an efficiency rate of about 20 to 30%, meaning a significant amount of energy is lost as heat. Electric engines, while more efficient at around 85 to 90%, still face challenges like long charging times and battery degradation. The water engine, however, boasts an efficiency of approximately 60%, placing it between combustion and electric engines. More importantly, it offers a cleaner, more sustainable alternative. Another critical performance metric is range. Traditional electric vehicles, EVs, often suffer from range anxiety, with current models typically offering between 200 and 300 miles per charge. The water engine, leveraging the high energy density of hydrogen, can achieve ranges comparable to or even exceeding those of fossil fuel-powered vehicles. Imagine driving a car that emits only water vapor and never worrying about running out of power in the middle of a trip. So, what makes the water engine so unique? Unlike electric vehicles that require lengthy charging sessions, the water engine can be refueled quickly, similar to gasoline vehicles. This convenience, combined with its environmental benefits, positions the water engine as a game changer in the automotive industry. One of the most significant advantages of the water engine is its potential to drastically reduce our carbon footprint. Traditional combustion engines emit large amounts of carbon dioxide and other pollutants, contributing to climate change and air pollution. In contrast, the water engine produces only water vapor as a byproduct, making it an exceptionally clean alternative. To put this into perspective, the average gasoline-powered car emits about 4.6 metric tons of carbon dioxide annually. Transitioning to water engines could eliminate these emissions entirely. Moreover, the elimination of nitrogen oxides and particulate matter would lead to significant improvements in air quality, particularly in urban areas. Comparatively, electric vehicles, EVs, are also cleaner than fossil fuel-powered cars, but are not without their environmental costs. The mining of lithium, cobalt, and other rare earth metals required for batteries has substantial ecological impacts. Additionally, if the electricity used to charge EVs is sourced from non-renewable power plants, the overall reduction in carbon emissions is less pronounced. Hydrogen fuel cells represent another clean alternative, producing only water as a byproduct. The production of hydrogen typically involves natural gas, resulting in indirect carbon emissions. Additionally, hydrogen storage and transportation pose challenges due to its low energy density and the need for high-pressure tanks. The water engine, utilizing reverse electrolysis, has the potential to offer a more efficient and environmentally friendly solution. By using renewable energy sources to produce hydrogen, the entire life cycle of the water engine becomes sustainable, further reducing its environmental footprint. Economically, the water engine could bring substantial cost savings in the long run. Traditional internal combustion engines require regular maintenance, including oil changes, exhaust system repairs, and engine tune-ups, which can be expensive over time. Electric vehicles have fewer moving parts, reducing maintenance costs, but still require battery replacements, which can be costly and environmentally taxing. The water engine, with its simpler mechanics and fewer moving parts, promises even lower maintenance costs. Components like fuel cells and electrolysis systems are designed for durability, potentially extending the lifespan of vehicles. As the technology matures and economies of scale are realized, the initial cost of water engine vehicles could decrease significantly, making them more accessible to the average consumer. However, the transition to water engines will require significant initial investment. Developing the infrastructure for water refueling stations is a massive undertaking. This involves either building new stations or retrofitting existing ones to accommodate water refueling technology. The cost and logistics of establishing a widespread network of refueling stations will require substantial collaboration between governments and private companies. On a broader economic scale, the adoption of water engines could reduce global dependence on oil, leading to more stable fuel prices and potentially reducing geopolitical tensions linked to oil supply. This shift could stimulate job creation in new industries focused on water engine technology, manufacturing, and infrastructure development. The introduction of the water engine represents a significant technological shift in the automotive industry. Transitioning from combustion engines and electric vehicles to water engines involves overcoming various challenges. The current automotive infrastructure is fully rooted in fossil fuels, from manufacturing processes to refueling networks. To address these challenges, companies can leverage existing technologies and expertise. For example, many principles from hydrogen fuel cell technology, such as fuel cell design and hydrogen storage, can be applied to water engines. This can facilitate faster development and deployment of the new technology. But what does the future hold for Musk's water engine? Will it redefine our approach to energy and transportation, or will it face insurmountable obstacles? The automotive industry has watched Musk's announcement with keen interest. Major players like Toyota and Hyundai, longtime advocates of hydrogen fuel cell technology, have had mixed reactions. Toyota, for example, has invested heavily in hydrogen fuel cells with vehicles like the Mirai, and Hyundai has introduced models like the Nexo. Toyota's executives view Musk's core as a validation of their long-standing belief in hydrogen's potential. They see it as a positive step towards wider acceptance and investment in hydrogen infrastructure. Hyundai, on the other hand, is cautiously optimistic, recognizing the competitive push, but also the significant market development needed to support both hydrogen and water engine technologies. The feasibility of the water engine has been discussed by analysts and industry specialists. While some regard it as a groundbreaking move that could hasten the switch to sustainable energy, others are dubious about the real-world difficulties. The technology's efficiency, the infrastructure needed for water refueling, and the viability of widespread adoption economically are among the issues raised. Public reaction to Musk's announcement has been a mix of excitement, curiosity, and skepticism. Social media platforms have been abuzz with discussions as followers of Musk and Tesla enthusiasts express their anticipation for the new technology. Many are intrigued by the promise of a cleaner, more efficient engine and the potential environmental benefits. However, there are also doubts and concerns. Some critics point out Musk's past criticisms of hydrogen and question the feasibility of a rapid transition to water engines. They worry about the practicality of building a new refueling infrastructure and the initial costs associated with adopting the technology. So, will Musk's water engine prove to be the game changer it promises? One of the most significant challenges in deploying the water engine is the development of a comprehensive refueling infrastructure. Currently, the infrastructure for traditional fossil fuels is extensive, with gas stations available in almost every corner of the globe. Electric vehicle (EV) charging networks are also expanding rapidly, thanks in large part to investments by Tesla and other companies. In contrast, the infrastructure for hydrogen fuel cells is still in its infancy. There are relatively few hydrogen refueling stations worldwide, concentrated mainly in specific regions like California, Japan, and parts of Europe. For water engines, which rely on a similar hydrogen-based refueling process, this existing network provides a starting point, but significant expansion is required. Tesla's approach to solving this involves leveraging its experience in building out EV supercharging stations. The company plans to retrofit existing EV stations with hydrogen refueling capabilities and build new stations dedicated to water engines. This ambitious plan will require substantial investment and collaboration with governments and private sector partners to ensure widespread availability and convenience for consumers. But how quickly can this network be established? What are the logistical and financial hurdles that need to be overcome? These questions are critical as Tesla moves forward with its water engine rollout. Safety is another paramount concern when introducing a new technology. Hydrogen, while a clean energy source, is highly flammable and must be handled with care. The water engine, relying on hydrogen, inherits these safety challenges. To address these potential risks, Tesla has implemented several safety measures. First, advanced hydrogen storage systems have been developed to ensure that hydrogen is stored safely and securely within the vehicle. These systems are designed to withstand high pressure and prevent leaks. Tesla's rigorous testing procedures for the water engine and hydrogen storage systems aim to meet and exceed safety standards set by international regulatory bodies. By prioritizing safety at every stage of development and deployment, Tesla is committed to making the water engine as reliable and secure as possible. But can these safety measures alleviate public concerns? What additional steps can be taken to ensure the technology is perceived as safe and trustworthy? Navigating the complex legal and regulatory landscape is another significant challenge for Tesla's water engine. Different countries have varying regulations regarding the production, storage, and transportation of hydrogen, adding layers of complexity to the global rollout of this technology. Tesla has proactively engaged with regulatory authorities worldwide to ensure compliance with all relevant standards. This involves extensive documentation, rigorous testing, and ongoing dialogue with regulators to address any concerns and adapt to evolving requirements. These efforts are crucial in overcoming regulatory hurdles, but what are the specific challenges in different regions? How will Tesla's proactive approach influence the adoption of this new technology on a global scale? Each technology has its unique strengths and weaknesses. Hydrogen fuel cells offer high energy density, allowing for long driving ranges and quick refueling times. They emit only water vapor, making them environmentally friendly. However, challenges arise in producing, storing, and transporting hydrogen gas, which is highly flammable and requires specialized infrastructure. Water engines present a notable advantage with on-demand hydrogen production, potentially simplifying storage and minimizing risks associated with hydrogen gas handling. Additionally, this method can integrate well with renewable energy sources, enhancing sustainability. However, the reverse electrolysis process requires significant initial energy input, which can affect overall efficiency. The market potential for water engines appears promising but challenging. The automotive industry is keen on reducing carbon emissions and adopting sustainable energy sources. Governments worldwide are setting strict emissions targets and offering incentives for clean energy technologies, creating a favorable environment for innovation. Forecasting adoption rates involves evaluating technological advancements, infrastructure development, and consumer acceptance. Initially, water engines may appeal to early adopters and environmentally conscious consumers. As technology improves and costs decrease, broader adoption is likely. According to analysts, water engines could gain substantial market share in the next 10 years if Tesla can resolve the issues with efficiency and infrastructure. To scale up manufacturing and deployment, partnerships with the public and commercial sectors will be essential. But what will it take for water engines to truly revolutionize the transportation industry? How will they compete with established technologies and navigate the evolving landscape of sustainable energy? The journey of engine technology began with the invention of the steam engine in the late 17th century. Thomas Newcomen and James Watt improved steam engines, revolutionizing transportation and industry. These early engines were crucial in driving the Industrial Revolution, powering locomotives, ships, and factories. In the late 19th century, the internal combustion engine emerged, developed by inventors like Nicolas Otto and Rudolf Diesel. Otto's four-stroke engine and Diesel's compression ignition engine became the foundation for modern gasoline and diesel engines. These engines offered greater efficiency and power, leading to their widespread adoption in automobiles, aircraft, and ships. The 20th century saw significant refinements in internal combustion engines, with advancements in materials, fuel injection systems, and turbocharging. These improvements enhanced performance, fuel efficiency, and emissions control, making internal combustion engines the dominant force in transportation. As concerns about pollution and fossil fuel depletion grew, the search for alternative fuel engines intensified. This brings us to the late 20th and early 21st centuries, where electric vehicles, EVs, began to gain traction. Companies like Tesla, under Musk's leadership, spearheaded the EV revolution with advancements in battery technology, range, and charging infrastructure. Before Musk's water engine, there have been numerous attempts to develop alternative fuel engines. One notable effort was the development of hydrogen fuel cells. In the 1960s, NASA used hydrogen fuel cells to power spacecraft in the Apollo missions, demonstrating the technology's potential. However, commercial adoption faced significant hurdles, including hydrogen production, storage, and infrastructure challenges. Another notable attempt was the development of biofuel engines. In the early 2000s, there was a surge in interest in biofuels, such as ethanol and biodiesel, derived from plants and organic waste. While biofuels offered a renewable energy source, they also faced challenges. The production of biofuels required large amounts of agricultural land and water, raising concerns about food security and environmental sustainability. Electric vehicles also represent a major shift in engine technology. Early EVs, such as General Motors' EV, one in the 1990s, showcased the potential of electric propulsion. However, limited range, high costs, and inadequate charging infrastructure hindered widespread adoption. It wasn't until advancements in lithium-ion batteries and the establishment of extensive charging networks that EVs began to thrive. The history of alternative fuel engines offers valuable lessons that inform Musk's current project. One key lesson is the importance of infrastructure. Hydrogen fuel cells and early EVs struggled with infrastructure challenges. Musk's plan to leverage Tesla's existing supercharger network for hydrogen refueling addresses this critical barrier. A further lesson pertains to the importance of energy efficiency. Despite being renewable, biofuels frequently used more energy during production than they produced. Musk wants to maximize energy efficiency by focusing on reverse electrolysis in the water engine, making sure that the process of splitting water and recombining hydrogen and oxygen is as effective as possible. So how does Musk's water engine fit into this historical context? It represents the latest evolution in the ongoing quest for cleaner, more sustainable engine technology. By building on the successes and learning from the challenges of past innovations, Musk is pushing the boundaries once again. A number of businesses and innovations could compete with Tesla's water engine. The Nikola Corporation specializes in trucks that run on hydrogen. In spite of numerous setbacks, Nikola has made significant strides toward creating heavy-duty cars that run on hydrogen fuel cells. Their emphasis on the business market may give Tesla fierce rivalry, particularly in long-distance travel. BMW is also exploring hydrogen fuel cell technology, having unveiled prototypes and committed to further research. With their strong brand and engineering prowess, BMW could present a formidable challenge to Tesla's water engine, particularly in the luxury vehicle market. Rivian, an electric vehicle startup backed by major investors like Amazon and Ford, represents another competitive force. While Rivian currently focuses on electric vehicles, their innovative approach and substantial funding could enable them to pivot towards water engine technology if the market demands. Working together is essential to the quick development and widespread use of water engines. Tesla has a track record of establishing tactical alliances to further its technological objectives. Gaining access to cutting-edge research, specialist knowledge, and cutting-edge technology can be accomplished by partnering with top tech businesses, universities, and research organizations. For instance, collaborations with universities focused on hydrogen research can help Tesla refine the efficiency and performance of its water engine. Partnerships with tech giants like Google or Apple could integrate advanced software and AI capabilities, enhancing the overall functionality and user experience of water engine vehicles. So, how will these collaborations shape the future of transportation? Will Tesla's partnerships pave the way for widespread adoption of water engines? The water engine's smooth integration with renewable energy sources like solar and wind power is one of its most exciting features. Utilizing electrolysis to create hydrogen using renewable energy, the water engine can run with very few carbon emissions. In order to produce hydrogen in a completely environmentally friendly manner, water is split into hydrogen and oxygen using electricity generated by solar panels or wind turbines. Imagine a scenario where homes equipped with solar panels can generate hydrogen fuel during the day and use it to power water engine vehicles. Similarly, wind farms could provide both electricity for the grid and hydrogen for transportation, creating a synergistic relationship between renewable energy generation and sustainable transportation. The impact on the energy grid could be transformative. Hydrogen production can serve as a form of energy storage, capturing excess energy during peak production periods and converting it back to electricity or fuel when demand is high. This ability to balance supply and demand can help stabilize the grid and enhance the reliability of renewable energy sources, even when natural conditions fluctuate. Global sustainability initiatives could be considerably advanced if water engines are widely used. Water engines can significantly lower greenhouse gas emissions and air pollution by moving away from fossil fuels. A more sustainable planet, healthier communities, and cleaner air would all benefit from this shift. Furthermore, the overarching objective of decarbonizing the energy system is supported by the integration of water engines with renewable energy sources. This technology has the potential to speed the transition to a totally sustainable energy environment by boosting the use of green hydrogen and encouraging the development of hydrogen infrastructure. When all of these initiatives are combined, the environmental impact of energy generation and transportation will be significantly reduced. Elon Musk's water engine could influence global energy policies. As countries seek to meet climate goals and reduce carbon emissions, the introduction of a viable, clean alternative to traditional engines may prompt substantial policy shifts. The growth of refueling stations and the production of green hydrogen might be encouraged by government subsidies and tax breaks, which would increase support for hydrogen infrastructure. These regulations can also include incentives for consumers to buy hydrogen-powered cars and funding for research and development. The shift to renewable energy would be accelerated by these actions, which would promote universal adoption and infrastructure expansion. The introduction of the water engine promises to dramatically enhance the driving experience for consumers. Unlike traditional internal combustion engines, which are known for their noise and vibrations, water engines, like electric vehicles, offer a quieter, smoother ride. This quieter operation enhances driving comfort and reduces noise pollution, making journeys more pleasant. When it comes to performance, water engines are comparable to electric vehicles in that they provide quick acceleration and instant torque. Driving can be more enjoyable and effective with this instantaneous power response. Furthermore, drivers may enjoy excellent performance without feeling guilty about the environment like they would with traditional fuel sources because of the water engine's pure energy output. Cost savings extend beyond maintenance. As the technology matures and economies of scale are realized, the initial cost of water engine vehicles is expected to decrease. Combined with potential government incentives and reduced fuel costs, consumers could find these vehicles financially attractive. Beyond automobiles, the potential applications of water engines are huge. Tesla is exploring the use of this technology in aviation, where reducing carbon emissions is crucial. Imagine hydrogen-powered aircraft that offer the same environmental benefits as water engine cars, potentially transforming the aviation industry. Maritime applications are also on the horizon. Ships powered by water engines could significantly reduce the environmental impact of global shipping, contributing to cleaner oceans and air. In heavy industry, where energy demands are high, water engines could provide a sustainable alternative, reducing reliance on fossil fuels and cutting emissions.